Preview this, make it a little bigger. All right. Ooh, I don't want to preview that. I want to preview this. There we go. So let's do that more formally. How are people doing? Doing good? Yeah? How was the homework for people who have been diving into it? It's more challenging? Anybody finished it? Yeah, I saw you did. All right. Oh, yeah, yeah. Yeah, grab whatever you want. Yeah. I think you can, there's an outlet right here, actually, that you might be able to use from over here, or if you pull the table over, you can use it. It's just on this side of the, yeah. All right. Well, today, just one topic again, trying to keep it pretty focused. We're going to do a quick review of arrays, although I don't have anything specific, but if you guys have any questions, then we'll go over that. We can also maybe go over one or two of the homework problems if those are something that people want to go over that were specific to arrays to help reinforce some of that. And then we're going to start discussing functions, which are one of the essential building blocks of being able to scale your code from tiny little bits of code like we're writing to larger code. Speaking of scaling code, we were just having a chat before class today, and it got me wondering how large different code bases were so that people can get a feel for just how much work it takes to build these large products. So here we've got a nice little chart that shows some of the different code bases and how many lines of code it's taken to write them. So if we look, we get to something like a simple iPhone game app, and this is a comparison in millions of lines of code. And we can see, you know, that's less than 1 million lines of code, right? That's somewhere in the thousands or something, maybe tens of thousands, potentially hundreds of thousands, but not that much. And then once you get to an average iPhone app, you're up to maybe 500,000-ish lines of code. So you've already grown to something pretty significant at that point in time. And I don't know if that's counting, I don't know where these numbers are coming from, if that's counting just the code that they wrote, or if it's counting all of the libraries that's also getting built into it. It might be, because that's a significant amount of code. I can say I don't think any of the projects I've worked on, well, maybe a couple have had about that much code in them, and that's been on large teams. So I haven't really worked on code at that scale for the most part, or even had to work in that large of a scale. Because when you're at that size, you usually aren't owning all of that code. You manage a portion of it yourself. And we start looking, by about the time you get to the first version of Photoshop, which is 1990, you've got something like 1 million lines of code. Yeah. And then we were discussing this because we were trying to figure out how many lines of code are there in like a game. And I said, oh, there's probably 10 million or more lines of code in a game today. And I'm thinking that I lowballed it now, potentially. No, we'll see, because the Quake 3 engine, which isn't even the whole game, it's just the engine, and that's a pretty old game, is sitting somewhere around 3 million lines of code, it looks like. Oh no, these are all 100,000, okay. I read this first line wrong. So these are like 100,000. Photoshop was about 100,000 lines of code. This makes more sense, 50,000 lines for an average iPhone app, and about 300,000 for Quake 3. That seems reasonable to me. That's about the right scale. And the space shuttle was about 400,000. And then we get to the newer stuff. So then we have, all right, here's a modern 3D video game engine, somewhere around 1 million lines of code. A more modern version, well, Linux kernel a little while ago still. That's somewhere around 1 million lines of code. Windows 3.1 was, I don't know, a little over 2 million lines, it looks like. And then Photoshop CS6, which is one of their more famous versions. You know, you've got 1, 2, 3, 4, between 4 and 5 million lines of code. And then you can see how we really start scaling as we get to larger stuff. Just the HD DVD player on the Xbox, not the rest of the code on that thing. Looks like it's 4.5 million lines of code. The Mars rover, rest in peace, poor guys. 5 million lines of code, roughly, right? Google Chrome, just your web browser, I don't know, 7, 8 million lines of code. And Firefox, closer to 10. And then you start scaling to the much larger items as well. You got like Windows NT, which is an older version of Windows. That's breaking that 10 million barrier. Android is 12 million or so. And then let's jump way up. We get to like say Windows Vista. It's around 50 million lines of code by the time we've gotten to the newer versions of Windows. So a huge scale up from Windows 3.1. Or that's one of the reasons I'm sure for Windows that it's growing so large, because Microsoft has a very strong commitment to being backwards compatible. And so there is a lot of old code that is still in the code base so that it can continue to function. If they deprecated some of that stuff, then they could probably shrink that code base a fair bit, but they don't want to do that because that might break somebody who has this one app that they've been running since Windows 3.1 that they still need to be able to run. Microsoft Visual Studio, which is a developer environment for writing code, is as big as Windows Vista. As many lines of code in as Windows Vista, which doesn't surprise anyone if you've ever used it, because it feels like it runs about that slow. Whoa, oh, hey. That was mean. That's crazy. Facebook, 60+ million lines of code. And then I have no idea what this number is. This is an estimate of all the internet services at Google, like 2 billion lines of code. That is a crazy amount of code. That's insane. Wow. All right. I hope people were entertained by that. I thought it was going to be funny. So that gives you an idea of scale, right? You guys have been writing stuff that's like 10, 15, maybe 20 lines of code right now. You're not going to write, those are, Windows has, I don't know, probably, if you're talking about the Windows team itself, they've been writing it now for 30 years, and they probably have anywhere from 500 to 1,000 people who write the code just for that and have been doing that. So that's, once you get at that scale, you really have to have these larger teams. But some of those smaller ones, the tens of thousands or even hundreds of thousands, those were pretty small teams. The Quake 3 team was just really a few developers who wrote most of the code for that. All right, moving on to our actual content. Let's talk about arrays. Anybody have any questions about arrays from the homework, from anything that confused them about how they worked? Yes? Okay, it's a good question. Let me see if I can pull it up. And then, what was it, lesson 6, homework? So let me see what the problem was. It was, which one did I encourage you to do? Like this one, print the even numbers. Yeah, first thing I'm gonna do here, because I don't wanna have to remember what I'm trying to write, is I'm gonna take my notes here. And I don't think I need this first line. That's not relevant. I'm actually just going to put them in my code as comments for the time being. That way I've got them sitting right here for me to work with. So we'll start off just creating an array, an empty array. And that's what we're going to be adding to going forward. And I know I want to go from 1 to 100. So I'm going to create an index and start it at 1. And then I'll do my while loop. While index is less than 100, I know I want to do something. And then the last thing you always want to make sure you do when you're looping through something is change your condition somehow to make sure that you're not going to get stuck there. So this is just the, I know I want to change my conditional. So now the next bit is how do we push them into the array? Well, let's just say at first, let's assume we're not even, I'm going to log what I have in my array here. And then I'm going to go ahead and run this just to make sure that my code is working. This is sort of just a sanity check at this point. I wanted to make sure that I was projecting correctly. So as a sanity check, scratch.js, and I get back this empty array back out. So far, I'm not getting any errors, which is good. So the next thing I want to do is, let's say I don't yet know, I know I only want to push even ones in here, but I'm not sure how to do that. So I'll just put a note here. I'm not exactly sure how to do that. And then I'll just do the push. So the push is pretty easy, actually. You just do this dot push, and then whatever you want to push into the array. And in this case, since I want to push whatever my index is or any of the even numbers, I can just push the value of index for this loop. And now if I run that, what I should get is an array. Oh, and I can see I already have something that's going to be a bug, so we'll come back to that in a moment. But I'm getting an array out of every number. So what's happening is every time it runs through, goes through this while loop, it just pushes another, whatever this value is, onto the end of the array at that point in time. Does that make sense?
Well, I created an array. I thought, it says add onto an array, so I created an array which is like 1, 2, 3, 4, 5, and then I was going to add an even number n. And so I was getting confused as to where I put that push onto my original array that I created that I wanted to attach to, or an even number. I guess that's where I was getting confused.
Oh yeah, I mean I get that.
The two different arrays I was trying to work with. Well, I ended up with 2 while loops, and I got the result I was looking for, but I did use it and wanted to.
Yeah, you were struggling with it was probably could have had a little more specificity at the start for this problem where it described it a little more specifically in terms of what you're starting with and what you're trying to go to, right? So you read starting with an array, add stuff to it. So you started that array with some values in it, and then we're trying to get stuff in there afterwards. Sort of makes sense. But then, so let's continue building this out. I mean, let's solve this one. May as well at this point. So I know I want to check if the index is even. How can I check if the index is even? What's that? What did you do?
I just did even Instead of doing like index less than 100,
Ah, see? That's a good way to solve it. I like it, right? And that's why there's no one way to solve this. In fact, if I were to make this a little easier, let's say, I don't want this conditional logic. I don't know how to do this. I can't remember how to solve that. So, but I do know I don't have to step by one every time, and I want even numbers from 1 to 100. So let's, instead of just incrementing my index, let's do index plus 2 each time. And now let's see what I get. Awesome, I got even numbers. But there is a bug there. Does anybody see the bug? According to the specification of what I'm supposed to give? What? That's right, I'm not getting to 100. So I want to include 100. I said from 1 to 100. So I need to change my condition to make sure that I run when the value is 100 too. And that's just one of those, reading the problem carefully. Yes? Is there a way to do it with continue? Yes. So let's go ahead and write out the other variant that I was starting with. We're going to start this at 1. We're just going to increment this every time. And then what we could do here is there's a couple different ways to write this. If we're going to step through every one, we could say, but we need an if block that's checking whether we're even, essentially, is the basics, right? And the canonical way to do something like that is you use the remainder, also known as a modulus operator usually, and you say if, oops, this isn't right. If index remainder 2, so that's basically saying if index divided by 2, if the remainder of that is 0, then that means that it's an even number. Pretty much the definition of an even number. And then we can say, oh, in that case, oops, only in that case do I want to add that index to my array. I don't want to add it in the other cases. And if we run that, we should get the right result. But if you wanted to use continue or you wanted to write it that way, we could flip this around a little bit. So then what we could say is, oh, I want this if statement to deal with the condition of the special case when it's not correct, but I want all of the correct code, like it is even, to be down here. So I'm actually going to change what we say here. Check if index is odd. And the way you basically check that is if mod 2 is 1, and it's an odd number. And in that case, let's continue. But you're going to see a bug here. So what this will do is what you want, except I think it's going to run forever. The way I have it right now, at least. Does anybody see why? There we go. It's hung. It's probably going to crash in a second and yell at me. Some sort of Stack Overflow issue. I don't know. You have to know that if you do that continue, you're breaking out of the rest of that loop. You're not running any of the rest of the loop. And so what we're missing here is we're incrementing the index after the continue. And so we're never actually going to increment that index because it's going to say, oh, I have 1. 1 is odd, so jump back to the top, run this loop again, etc. So one way to change that, if we wanted to fix that behavior, it's a little weird, which is why you probably wouldn't write it this way. It's sort of unintuitive, but you could. Is let's say, well, I want to do all of them from 1 to 100, but in order to just capture this logic in this fashion, I'm going to start at 0, and I'm going to do that because I'm going to increment my index as the first thing I do. And that way, this part will always run before the continue is hit. Now there might be, I'm not sure if there's a bug with this. We'll see. I think that works. But that's the type of, those are just several different ways to write that same program. And none of those are the right way to write that, just different approaches. This one is probably the hardest one to understand immediately because it's got some tricky logic in there. Any questions on how we solve that? No? All right. Is there anything else that caused some confusion working with arrays besides the push?
I have 9 questions. So, there's a question online today about who said he was trying to run a file that didn't do anything. Even after he saved it, then when he saved it as a new file and ran that new file, it never. I had a similar problem over the weekend where I had run a program or written a program, and then I changed the file and saved it and ran it, but it ran as if I hadn't changed the file or saved it.
Right.
So it like ran the original program instead of when I changed it. But I don't know if anyone else has noticed these problems last time.
I've heard somebody else mention it too. So what was mentioned for those who are remote was a problem in Cloud9 where you change the program, you save it, you know you saved it, you run it, but you're not running the newer version of the program. It seems to still be running the old version of the program. But when they chose save as, saved it with a different name, it did seem to work correctly when they ran that. Now honestly, I know there's some quirks in the way that Cloud9 works, and so I'm not going to be able to give the perfect answer to all that. One question I have is, were you using the run button to run your program? Or were you running it down here directly, invoking Node?
I was running something in the browser, so I was just running an HTML file, and then it worked. It was the same thing. Like if I saved it as a new file, ran that, and it worked fine. And then, but I guess Richard was doing it both by using the run button and by hiring Node.
Okay.
In the terminal. So
in the browser, a likely reason that that's happening is because I'd have to double check some of the stuff here, but it might be, your browser might be caching the file that.
Because I like close the window, I log out of that and log back in, and it's still the same.
That seems like it shouldn't be the case then. Then I'm not 100% sure, but at first I was thinking, I could double check some of that, but it might be, there might be a case where the browser could be caching that file and it sees that you're just requesting the same file, so it serves up the one that it already has. And by changing the name, and obviously changing the name and the path, and when it tries to request that file, it sees it as a different file. I'm not 100% sure if that's what's going on there.
Yeah, I don't know what Richard.
If you do encounter that when you're in the browser working with something, one way that you can try to bypass that is, this isn't as easy in Cloud9. I don't know if it's going to work if you're doing the preview mode of it versus opening it in a separate tab. But if you go to your network tab in your browser, for Chrome at least, and the same thing exists for, say, Firefox, there's a disable cache button up here, and that will guarantee that none of the files that it serves up are it's going to request fresh files from the server all the time for everything. So that's one way to, bypass a stale file in your browser. I don't know if that's what was actually happening or not, but. That might just be one of those that I'm not going to be able to get the answer without seeing it live.
You also, before you kind of get started, have people make sure they're on the Slack channel.
Oh, chime in? Yes, thank you. Appreciate that. I meant to say that at the beginning too. If anyone who's watching on Slack, please just speak up. Let us know that you're here. We're starting to try and just get attendance so that we actually know who's in the classes, who's attending. And that will help us know that you're active, you're on here right now, and we'll be able to mark you down. And if you watch it afterwards, don't worry. The attendance isn't some formal thing. It's a gauge for us to just make sure that we've got some sort of rough count of what's going on and get a better feel of how many people are there live versus later and stuff like that. So if you're on remote right now, please go ahead and just speak up in Slack and we'll get you tracked in that tool. All right, any other questions right now? Cool. And we're going to talk about functions today. Functions are one of those really fundamental building blocks of programming, but especially in some languages like JavaScript, they're even sort of more fundamental. So to start off, let's just step out of programming for a second. And let me just ask, where are people familiar with the term functions? You probably encountered a function before in some other scope outside of coding. What? Math, right? So what's an example of a mathematical function?
It gives you an output, like you put in an input.
All right. Can you like give me the simple one or something to start with? A plus B equals C. Yeah. I mean, that's fine, right? And a lot of times you'll also see them written like this. I'm going to leave that up there. A lot of times quit giving me weird code completion. No. You'll also see functions written like this in mathematical notation a lot of times, like f of x, which is saying, oh, when this is a function that takes in x as an argument and then it does something, right? It returns x times 2. That look familiar to people from math? All right. And the reason I do that is to try and help bridge this gap. Functions in code are very similar to mathematical functions, but they have a few quirks that are a little different in how they behave, but for the most part, they're intended to be conceptually very similar. So how did you describe a function again? You give it an input and you get an output, right? Or you give it some inputs and you get an output. So if I were to rewrite this one with a more function syntax, it might be like, this takes A and B, and what it returns is A plus B, right? It's more of that direct function notation. That's exactly the same as the definition for a function in coding. Functions is a JavaScript procedure, a set of statements that performs a task or calculates a value, and I missed the bit here that says return something. It's just worded a little differently in this case, but that's pretty much the exact same thing that a function in a programming language does. It takes some inputs and it gives you an output. Now, one of the differences, and we won't emphasize this too much, but one of the differences between a function in programming and a function in math is a mathematical function, the only thing it can ever do is give you the output based off what you put into it, right? It does one thing. Programming functions can have side effects. They can do other things because it's just a way to organize code. So it's not all just inputs and outputs. It might have what's known as a side effect. And we'll see that in pretty much one of the first ones because it's a little easier to introduce stuff with side effects. Key with functions, just like what we did in that little scratch page there, is to use a function, you must define it somewhere in the scope from which you wish to call it. So we define like f of x there, and it's just x times 2, and f of a and b was a plus b. And then you run code in a function by making a function call. And the last bit is a function, after a function completes, the program returns execution to the calling code. So this is pretty much this right here, and I've got a link to the MDN documentation on it, is the specification for how you write a function definition, or also called function declaration or function statement in JavaScript. And the process for that is it starts with the function keyword, and then it's followed by the name of the function. That's one thing that's different between mathematical notation and programming function is most programming functions have names. Then you have your list of parameters. That's a lot like that x or the a and b that we had in the mathematical function, enclosed in parentheses. And all of the logic for it, what it's actually going to do, the JavaScript statements that define it are enclosed in curly brackets. So here's, copy all this over and move it over into my scratch.js file. This is a very basic definition of a function. We've got our function keyword so that we know that we're starting a function, the name of our function, which is called print hello. It doesn't, oops, I don't want that. Doesn't actually take any parameters. There's nothing in here. And then inside of it, it calls console.log. And so we've declared the function here, but it doesn't actually execute at that point. So I've got a couple other console logs in this code and a couple calls or invocations of print hello to give an example of what it means when it actually runs. And if we run this, I did not save it. If we run this, we should see that we output start program, then hello world twice, and then end program. And so what you're seeing there is that this function, while it was declared here, none of the code for this actually ran at that point in time. It only ran when we called the function. So what we've created is a reusable block of code that we can call at other points in our code to do that same thing over and over. Is there any questions on that? Does that make sense? Give it a moment. All right. Move on a bit. I'm going to close this. Don't save that. Close that. Get this back open. Preview. So that's just about one of the most basic functions you could have. But one of the interesting things in this is you said you get a result out of a function, or this one doesn't actually return anything. This console.log is what's known as a side effect in this function. It's doing something, but it's not returning something from the function. So, sort of lied there, because all functions actually have a return value. Every function in JavaScript has a return value, and it can only return one value each time it's called, but each call could return a different value. Just like that, you know, f of x, x plus 2 or times 2, you could put a different value in for x and get different results out. That's the same way that it works here. So if we take another look at this print hello function from before, does anyone have any guesses what the return value from this function is? Probably not. Just, you could say something completely random. 42. What? Yeah, yeah. What do you think? What do you think the value of return is going to be? Hello world. This is a little bit of a trick question. I don't expect people to actually. Oops. I don't expect people to actually get this because they haven't seen it before. But the key is, what I'm getting at is every function has, actually I need both these lines. Every function has a return value. It doesn't matter if you explicitly return something from your function or not. So I'll just add these lines here. And we'll see what happens with this code now. When I run it, is now we printed out hello world. We printed out hello world again. We did it a third time, and that's because I called the function 3 times. But the last time I put the return value from it into this variable and printed that, and that is undefined. And the reason it's undefined is because we didn't define a return value. We didn't tell it, what do we get back from this function? So what I'm going to do is change the way this function works so that instead of it logging directly to the console, I'm going to return a value from it. And the way you do that is with the return keyword. Let me change what it says too. Something a little more fun, and a quote from one of my favorite movies of all time, Bill and Ted. So now Oh yeah. Oh, I already, you missed earlier when I mentioned Punky Brewster shoes. I mean, I'm all over the place today. Solid 80s kid right here. More 90s, but you know, I'm born there. So now we're returning a value from our function. So if we look at this whole program, let's take a second and take a stab at what we think is going to be output from this program line by line. What do we think the output's going to be? Let me simplify it a little bit too, so that we don't have quite as much. There we go.
You're gonna get print below it, then you're gonna get, instead of undefined, you're gonna get previous minus the trends. There you're gonna get.
All right. So the guess was we're going to get the start program and then the greetings, my excellent friends, and end program. Let's see, and that's what we get. And it might be a little tricky there because you're thinking, didn't I call it here and here? And I did, but in this case, we just didn't do anything with the return value. And since this doesn't have any side effects, the only thing it's doing is returning a value. When we invoked it here, it did nothing else. It returned a value that we did nothing with and continued to run. In this case, it did the same thing. It has no side effects, returns a value, but then we print that value here. Swing back over to this. Does that make sense? The idea of working with return values from your functions versus console log being a side effect or other things like that. That part's probably a little more confusing. It's a good question. Should you use return as a normal practice? It depends. I mean, you'll hear different positions from people on this. We'll talk more about code structure and separating stuff out. Sometimes you'll have a function that is sort of that side effect type function that I just want this to print something, output something to the console. And that's okay. But a lot of times, I would say more often, what you're getting out of a function is a return value. And what you're really leveraging from the function for is to be able to encapsulate a bit of logic so that you can use it again or give it different values. And so the return value, I think, is really the powerful aspect of the function. Otherwise, it's nice to be able to group something and not think about it, but the return value is the powerful part of working with it. It's a really good question. So this is just that exact same program. There we go. And we just used return to get a return value. Another important thing to know is that functions stop executing immediately after running a return statement. No further code in that function will run. So just like we already saw an example of something like that earlier when we were working with that continue, where when it hit continue inside of that loop, it didn't run anything else. It works the same way in a function. So if I take this and I put this console log into my function that I had up here, you'll see my editor is even being nice enough to warn me. It's got this, it's sort of dimmed out. That's because my editor's smart enough to say, this code can never be reached. It's never going to run. Oh, geez. I've had those in my early days of programming. So if we run this, you see that it doesn't log this line. And that's because we have a return statement above it in our function that will always run. So this console log is never going to get printed out because the rest of that function won't execute after we've returned. Does that make sense? Yeah? You guys are going to get a lot of hands-on with working with functions and practice with this stuff. So don't worry if it doesn't all click perfectly right now. Hopefully after working through quite a few programming problems, it'll start to make more sense. All right, so moving along pretty quickly through this. Am I moving too fast? If people want more hands-on examples, because I can do that too. More examples? Okay. Let's do a slightly more complex version of this. Well, I'm trying to think. What can I do? What can I do?
Add an argument.
I'm gonna get there because that's like a couple items down. That's what I was thinking. I want to add an argument and then I can do something more complex. So I guess I'm gonna get a couple more down and then I'm going to come back to that same one we just had without executing stuff, and I'll show a more complex example that'll compose even more of that. But the next thing I want to do is let's add some local variables, and then we'll add an argument because it's sort of the same type of concept. So far we've declared variables, but actually every variable we've declared in our JavaScript code up to this point has been essentially global. It's available everywhere, right? That every bit of code that you have can reference that variable name. So a local variable is just a variable declared inside of a function. And local variables are limited to just that function. You can't access them outside of the function. What we refer to that as is the scope of the variable. So in other words, that variable has function scope. It only exists inside of there. We'll talk a lot more about scope as we start building more complex programs, because scope is an important concept to understand when you're building stuff up. What's the scope of this object? What's the scope of this variable? What's the scope of something? And when is it out of scope? So if we take this get hello program and we'll rewrite it one more time with a local variable. Well, I took everything. All right, let me get rid of all this then. This line and this line. All right. So now it's doing the same thing, but what we've done is define this local variable of hello to hold the string, and then we return that. And if we run this, we should hopefully, must have a bug somewhere. Oh yeah, I know what my bug is, silly me. That was intentional. Let me get rid of the second line first, and then we'll run it. So if I get rid of that, and I run this, we see start program, hello world, end program. So there's a couple interesting things about this. We created this variable inside this function, and we returned hello, and we were able to log that here. So that tells you that whatever this string was actually available out here. We returned that string, but if we tried to console log the variable hello as opposed to the return value from our function, that was what caused the error. And it says, reference error, hello is not defined. Which is exactly what I was saying, is that hello isn't defined outside of this function. And since this console log statement is not inside of the function, it doesn't exist. So if instead I did put it in here, and I'll get rid of this one again, I don't know. Yeah, it's fine. We can reference it all we want inside of the function, but once we exit that function, we don't have access to that variable name anymore. I got 2 because I logged the output of it here, and since I'm returning the string hello world, it's logging that a second time here, and I'm doing it here as well.
Doing it once the side effect inside of the function, all of the function, outputting.
Yeah. Yes, is there another question?
Yeah, so let's say we have so we're able to reuse the same variable name inside each. So let's say I have an example of 2.
Good question. Yeah. So the question was, if you have multiple functions inside of your code, can you reuse the same variable name inside of each function? The answer is yes. And let's do an example of that. So again, this is the boring hello. So let's have a more fun one. Function better hello. Oh, I didn't need this or this, and my indentation is going to be wrong, so let me fix that too. There we go. And so, I don't know, does somebody have another classic hello greeting?
Hola mundo.
What?
Hola mundo.
Hola mundo? Is that right? All right. I'm going to get rid of this console log in each one of these because that was showing something different. And here, I'm just going to change this line to call better hello and log the result out. And you'll notice each one of those used the same variable name inside of them. But it looks like it works just fine. And that's because the scope of that variable name is only inside of that function. And so you can actually redefine it in other functions. Each one of them, it only exists within there. And it only exists within that execution of that function too. So each time you run that function, it's a different variable. So let me use an example of that. I'm going to write a function. I like my better hello, I'm gonna leave it. I'm gonna write another function. We're gonna call it getRandom. And this one, I'm gonna set a number, which is math.random. And I don't care that this is, I'm not gonna make it a nice even number, because what actually math.random returns is a number between 0 and 1. And so this is just gonna be some sort of little fraction thing. I'm just gonna run it up here. If I log the return value from this, and then copy that a few times. So we're executing this several times. What you'll see is each time we call that function, it does another math.random call, which gives us another random variable, puts it in this num, and returns the current value of that. So it's not going to be the same every time we call it. It's only within one, like, oh, we called it, it creates it, it exits the function, and then it just deletes that variable. It doesn't exist anymore. Make sense? People okay with that? I've seen some peculiar looks around that, but all right. Yes.
One thing I've noticed is that in general, it seems to be that when you declare a variable, it's kind of like a noun, and you declare a function or like a verb. And I think it's a good coding practice because variables tend to be like things, and functions tend to perform an action. It's the way like nouns and verbs work. Which it kind of helps when you're coding to keep track of like what's a variable and what's a function by kind of following that style, where functions just tend to be like verbs like get random or print hello or get hello.
Yeah, that's great. I'm going to reemphasize it for the people who are remote because they weren't probably able to hear that, which was, he was just pointing out, and these are the things that you forget when you've coded for a long time, they become natural, and there's something that it really helps to explain, is functions tend to be more like verbs, and variables a lot of times tend to be more like nouns. So, you know, here we have num, which sort of describes, it's like this is a number. It's just me being lazy, not typing out number. Whereas my function is getRandom, or this one said better hello. Probably would have been better to name this like say hello differently, but this one's like get hello. And so that's sort of describing an action. That's a very common paradigm. In fact, some places will actually try and enforce that as part of their code policy, is your function should read this way. And some of them will even enforce, and you guys don't need to get into this just yet, but some places will try and enforce specific types of function names. So if you were to take a guess here, we've talked about return values. We return numbers, we return strings. If you were to take a guess, if we defined a function is even, and don't worry about the details, what type of value do you think you might get back from that? A number? So let's assume what we're trying to do is check if something is even. What? A Boolean would be a good idea. Because, I mean, a number is fine too, but a Boolean is sort of the common thing for something like that, because you're asking a question that has sort of a yes or no answer, almost. Is this an even number? Yes. Okay, cool, right? And so you'll see people who, a lot of places will encourage naming conventions like that, where there's certain things like is, has, a few others that if you start your function name with those, it implies that that's going to give me back a Boolean as my return value from it, because it's sort of just asking this yes or no question. And then you'll have other ones like get as the start of a function name that implies I'm getting something back, but it could be a lot of different things happening. Or that, you saw print as one, that you're sort of reading it and saying, this function's probably printing something out to the screen somehow. I don't know exactly what, but just reading it implies that's what it's doing.
Also, know when you find a function that it looks like it appears in suggested options.
Yeah, at least in Visual Studio Code, it's really nice. It's showing me the functions that I've defined. And so I can use tab completion and up and down arrows to invoke that function or to not have to type it all out. That's really cool. I think that same thing exists in Cloud9 too. I think it shows you your functions that you've defined. How are we feeling about local variables in our functions? Okay. Jumping down, I really need to.
It is worth thinking about how you name your variables and your functions. I think that's something that I still really actively think hard about. Make it readable, not just like something that I slap together that makes sense to all people. So it's worth kind of giving that some thought and trying to be in your to kind of think so as best you can.
Well, anyone who is on the last call also heard my bad classic programmer joke, which is there's only like 2 hard problems in computer science: naming things and cache invalidation, and off by 1 errors. But naming things, that's a joke, but it's very true. Like, naming things is a hard problem. And there's a lot of code. You want your code to be readable. We'll talk a lot more about that. As you start building larger things of code, larger bodies, you want one of the benefits of a function is there may be a lot of complexity behind a function. There may be a lot of things going on. So imagine I'm going to write a function I'm going to rewrite our original one that we had, which was print hello. And it's going to do a console log hello world. But imagine, and this could totally happen. Imagine instead you don't have an easy thing like console log to call. You have to initialize some stuff. You have to create a connection to the place that you want to print this out. You need to say how you print it. You need to define the HTML, etc. And I'm going to use a nice little feature of the editor here to collapse this. So if you don't see the body of that, one of the nice aspects of this is you can infer a lot about what this is intended to do just from the name of that function. And you might be able to not even have to worry about the details of it. You might be able to say, oh, I don't actually care how it does what it does. I just know from reading it that it prints hello and I need to print hello. So that's a really useful thing to do. Whereas if I had named this, and you'll see some people who might do something like that, PH, short, oh yeah, well that's short for print hello. Of course that's short for print hello. And then tomorrow you're not even going to remember that that's what that was short for. I know that in my first programming class I took, this is confessional time, right? I'm in like the priest booth here. is she started teaching us with single letter variable names like X and Y. And it wasn't until 2/3 of the way through the class that we were taught that you should give proper names to things. And by then I was lazy and I'm like, there's no way I'm giving better names to my variables. And so I wrote an entire blackjack program, just starting with A as my variable name and working my way up. I think I got into double letters like BB before I had all of the logic that I needed for all of my variables. Yeah, that did not make my teacher happy. Oh, that code worked flawlessly because I was threatened that I would fail if there were any bugs in it. I spent a lot of time making sure it worked just so I wouldn't have to put meaningful names on things. That's horrible. That was a good conversation about naming stuff. We'll definitely talk a lot more about that over time. So the next topic, building on local variables, very similar, is parameters and functions. So if we can get something out of functions, we already saw our earlier version of the mathematical functions like f of x, where x is a value you put into it and you get something back out. You can do the same thing with programming functions where you pass something into it. They can take what are known as parameters, and those will act like local variables inside of the function, and they're declared within the parentheses after a function name. You supply the values for parameters when you call the function, and this is a little confusing. They're parameters in the declaration of the function, but when you call a function, you're providing arguments. Those arguments are the values for the parameters of the function. And different arguments can be provided each time you call the function. So let's go back to our hello world and let's make it a little more robust than what we had before. This time, we've added a name parameter. Look, it's even nice enough to tell me, parameter name. And when we call it, we're providing a value for that name parameter within our parentheses here when we call the function. And this allows us to reuse this function and reuse the logic in it. So now, the same function can print different things based off the values that we pass into it. And now we've got something, other than the fact that this is a pure side effect, it's not returning the value right now. This is much closer to that full concept of the mathematical function. We just built it up bit by bit in code. A question about passing in just a single parameter to a function like that? All right, so here's what I'm going to do. We'll come back and talk more about parameters, but let's revisit, because I feel like I've got what I need now, the question about more examples of some stuff in the function and returning values, or even an example of how return prevents other code from executing. So I'm going to go back to what we had there, and I'm going to leave this console log here. And what I'm going to do is, I'm going to change this. This one's going to say, I'm going to go back to what we had, right? This should, I'm not sure. This is, I'm not kidding. This is a type of line I might put in code that I'm working on that I'm not sure why it's working a certain way or something. This is literally the type of thing I might put there. Did we reach this code? Like, I don't know. Did we reach this code? And what I'm going to pass in here is should return early. And so this is a much more complex example, but I'm building out what's going on here. There's a lot going on in this little function now, because what I've changed is I've changed the parameter to something called should return early. Anyone want to take a guess what type of value I expect to pass in there? I think it's a number, string, a Boolean, undefined, string. I'm going to go with a Boolean. Sort of a yes or no type thing. Should I return early? Right? It's a little weird here because it's a variable name that reads almost like a function name. And then I'm going to run this. Let me see what I do here. Because this is just say hello, I'm not going to return this value. I'm going to console.log. Make it a little easier. Returning early. Now I'm going to change these calls, and I'm just going to pass in raw Boolean values to test both variants of this, false and true. And one thing you'll notice here before I even run the code is, you notice my editor no longer tells me this is unreachable. So it's already giving me an indication that something's different between this and the previous version of the code. And if I run this, oh, this guy didn't actually return. Stupid me. Let me return. You can do a return like that as well. That's just returning undefined. I'm not returning any specific value. There we go. I want to return. And so what you see in this case is I'm calling it 2 times. I'm calling it with false the first time and true the next time. And when we call it with false, it goes into the code. It says if false, well, this is false, so it's not going to run this. Then it runs, did we reach this code? And that's because we didn't return at this point because we didn't actually run what was in this if block at all. And then the next time I call it, I pass in true. So now it's going to run if true, well, true is true, or truthy. So it runs this code, which says returning early and actually returns. And because of that, it doesn't print out the console log statement here. So that's a much more, really compact, but much more complex variant of a function. And you can begin to see how even in just a few lines of code, we've got a lot of complex logic going on that really changes behavior. I didn't necessarily plan to write one that was going to be that complex or that dense, but I think it's a good example. Double check. I think my next example of function parameters is much simpler. I'm going to switch over now. We're going to write something that's much closer to just this pure mathematical function. Let me get rid of this line, comment out this whole line for a second. And now in this case, this is all very similar to what we had before, except we've just got an add function. What's going on here is you can pass in more than one parameter to your function. You can actually pass in pretty much as many as you want. And you just separate them with a comma in between them. And usually it's convention to put a space. You don't have to. It could be A, B like that, but it can get a little hard to read, especially if you've got a long list of variables. So putting a space is sort of a common convention. And all this is doing is returning the value, the sum of these two items. So if we call this, run this program right now, get back 12, and that's because if we walk through it line by line, up here, let me get rid of that indentation. Up here we declared our function, but it didn't run, it just knows that it exists. Then on this line, we run or call our function with the values 5 and 7 for A and B respectively. That returns 12, which we store in the variable sum, and then we log that out. So that's a pretty bare bones example of a set of function invocations or a function invocation. Does this much make sense at this point? Yeah? Now, once again, I had this here just as an example of variables are local to your function and not available outside. So in this case, I'm trying to console log A, but A is a parameter to my function. It's pretty much the same as a local variable or very similar. So it's not going to be available out here, and it's going to yell at me. This is undefined because A doesn't exist. A is not defined. That's because it's only within the scope of this function that it'll exist. Yes? So functions, that was one of the key bits about how functions work in JavaScript specifically. Functions can return one value and only one value. So if we wanted, this function could just return A, but then we're not getting, no, we're not getting A as a variable. So you can't get the variable, you can get the value. So let me get rid of this line. So you can't get the actual variable back out, but you can get the value. But in that case, it's not doing what we want. If you were, we can talk a little bit more later about how you could accomplish something like that. But let's say for whatever reason, right now, let's just try and say, well, really what I want is I just want to get A and B back out of my function. I want to get both of those values out of my function. I said I can only return one value. Anyone have an idea how we can solve that? You could, but you're not really getting them back out of it. I'm just posing a problem that is a challenge. I don't know. We might be able to use a tool that we learned in the last class. What? What was that? I mean, yeah, like, let's say I can do this. And so it's not really adding, but now I get them back out. I just got them in an array. And the key there was I still only returned one value from my function. In this case, though, that value was the array, which had different values inside of it. Right? So you don't have to return one string or one number. You could return an array from your function. That's still one value. And if we wanted to, like, oh, what I want to get back are what I put into it plus the sum of them, then maybe I do A, B, and A plus B as the array that I return. And what I get back are, oh, here were the arguments I passed in, and then there's the sum. Now, you'd have to know ahead of time that's what you're getting back. So you'd have to say something like, oh, that's not normally what you would expect, so I'm going to put a comment here that says returns an array containing the values of the arguments passed in, followed by the sum. Right? That's just giving me a note so that when somebody else comes and runs this, they'll be able to figure out why the heck is this giving me an array back? It's because it's what we wanted to do. It made sense in this case because we cared to know what the values were that we passed in for whatever reason. Yes?
So rather than explicitly specifying the arguments when I call the function, can I pass a globally declared variable into that function? Like if I just
Yes.
if I wanted a different number than 5 instead of.
Yeah, let's change this back. Let's just return A plus B. And we can totally do that. My indentation's driving me mad. So let's just create some values here. Var first equals, let's just act like we're buying some stuff here. I don't know. 495. Var second item equals 999. And I can pass those in as my values for this. Get rid of this line because it's just misleading. And what I get back makes no sense, right? People are confused. Let's see hands. People are confused by that value? Is that not what you expected me to get back? What should 495 plus 999 be? $14.94. But look up what the heck is up with all those zeros? Oh, those little zeros in that one down there? Don't worry about those little zeros in that one down there. No, we could get into that, but the maybe I'll do a short talk on it at some point. That's has to do with the fact that there are, when computers are trying to represent decimal numbers, they actually use sort of an approximation. They can't represent all of the decimal numbers perfectly. And that's why it's known as floating point. It gets into how it works inside of a computer. So sometimes some of the numbers can't be perfectly represented with inside of your computer, and so it gets a little bit off. Another example would be, let me see, I think I can do it just right here, 1.01 plus 1.02, I think. Boom. Math doesn't work. This is how computers work. It's really annoying when you encounter these types of things. There's stuff to help you deal with it. It's not that common that you encounter these issues. Depending on the domain you're working in, it might be. But in a lot of domains, you're not really encountering these types of issues because a lot of domains, a lot of web stuff, you're just working with integers, or you're just going to chop off those extra variables, and there's tools to help you do some of that stuff as well. But it does mean that you can get some weird results sometimes when you feel like stuff should work. It doesn't give you back exactly what you think it should.
Anyway, I asked the question because I think it's a more common way to call functions using previously declared variables that would be to like hard coding actual numbers.
Very much, right? If we have now a third item, you know, we're going to have some other stuff that we bought. This cost $15. And this one was just 99 cents. You can call it a second time. This time I'm just going to be really lazy. I'm not going to put it in a variable. Add third item, tab completion, baby. So nice. Fourth item. And now we're calling this thing twice. It's a little different than what you expected because this console log was below, right? Somebody may have thought they didn't print in the order they expected. It's because I was actually printing the result of the first evaluation second evaluation first. But you're right, that's very much what's much more common is using predefined variables, using values from somewhere else when you call a function. And once you start composing stuff that way, you get a lot of power and flexibility out of what you can do in your code. Questions on that? Another important thing, sort of glossed over, is parameter order matters. Because when you call your function, when you invoke it, you just pass them as comma-separated arguments into it, whether you're using variables, whether you're using hard-coded values, but those map directly to the items up here. So, you know, if I defined a subtract function, a minus b, and I call it with 158, that's the equivalent of a is 100, b is 58. And if I call it with 58 and 100, it's the other way around. And that's just because that's the order of the parameters that matters.
Can you still specify them in the opposite way if you write b equals a equals 100?
Not in JavaScript. You can't use, JavaScript doesn't support named parameters. Unlike, I think Python supports it, Ruby supports name parameters. A lot of programming languages support name parameters. JavaScript does not support named parameters. So, which is a little bit of a disappointment. It's a little nicer and more explicit, lets you do some tricky things with your code sometimes too, but questions on this stuff? Yes?
You can ask for a reference.
We'll talk a lot more about that later. But yes, I'm really going to dive into that. I think I'm actually going to dive into that with a homework problem, because I like the idea of introducing concepts in a homework problem and then having people go, what the heck? Why does it do that? And then explain it again later. But we'll talk about pass by reference and pass by value and what the difference is. You can't explicitly choose. It's predefined in the language that the primitives, number, string, Boolean, I think null and undefined, although it doesn't matter that much for those, will all be passed by value. And objects, what else are there? I think I'm missing one other type in JavaScript. Objects will be passed by reference, no matter what. So for the people who are confused by pass by value versus pass by reference talk, don't worry, we'll get there. Just focus on functions right now and getting a handle on them, and then we'll get to the really confusing stuff, because that's I think gets much more confusing than functions. Functions by themselves feel nice and contained and easy to sort of understand. Any other questions right now? All right. So just want to talk about some of the benefits of writing your code using functions, and then we might take a break for just like 5 minutes. If people want to step out, they can, or if they want to leave, but I'll stay around and continue the video and answer other homework questions if people have questions on that stuff as well afterwards. But some of the benefits of functions. The first one is, any good programmer is a lazy programmer. And functions let me be lazy because I can write code once and reuse it multiple times. So I don't want to write that code again. I want to write it one time and not write it again. That's what a function really lets me do. It lets you use the same logic with different values. We saw that with add, we saw that with subtract, or the say hello where we passed a name in. You get to pass different values into your functions, and that gives you a whole bunch of dynamic programming capabilities that you don't have when you're not writing functions. And then a couple other ones that are, or some other ones that are much more about the way you think. It lets you break your code up into smaller pieces. So far, we've been writing all of our code in one big continuous block. Functions let you split stuff up into smaller pieces. And if you remember, one of the top lessons I said for becoming more effective at programming is to think about stuff, break it up into a smaller piece, solve a smaller problem first. Functions will let you do that. And we'll get into working with them and composing them, putting multiple functions together. That'll really help us with being able to think that way. It lets you isolate variables in logic so that they're not affecting other bits of code. And then perhaps the most useful aspect of functions that will be much clearer. Wow, I got really loud. I'll turn it over that way. That will be much clearer as you start building bigger programs, is it allows you to abstract away a lot of complexity with something simpler. And I'll talk a lot more about abstraction. I think I already mentioned it before, but probably if you want to just think about what a good abstraction is, a good example of an abstraction that you work with pretty much every day is the steering wheel in your car. The steering wheel in your car, when you turn it, there's a lot of stuff going on under the hood of your car in terms of a rack and pinion moving back and forth, your wheels being turned in tandem, being kept in sync. And I'll bet you maybe one or two people here knows how most of that stuff works if they're a gearhead and really love vehicles. I don't know how it works. I don't have to know how it works. That steering wheel hid all of that complexity from me. That's one of the biggest benefits of working with functions is you can shove a lot of complexity somewhere and then not worry about it again unless you have to get into it. Any questions about that? All right. I'm gonna put a small timer up, take a break unless, does anybody want, let me just double check, because if not, we can end early, but does anybody want to work through any of the homework problems that you have questions on? Think we should? Okay. Then we'll take a quick break. Let me throw a timer up. For the people who are remote, I'll do, what time is it? I'll do like a 3-minute break. And then we can come back and maybe work through some of the homework problems that we had. Turn everything off. Haha, almost perfect timing. All right. Open up this homework file. And then what problem does somebody want me to maybe work through, or we can even work through it collectively if you want from the homework? Yes.
So I got interested from, I was trying to figure out how to extract just the odd numbers. And I came up with something that's a filter. And so I was trying to use something maybe one line. And I want to filter out, the numbers that, divided by 2 with a remainder that's not. And I'm trying to pull those out, and I don't think I set that up right.
Yeah, that's, I mean, that will work. You're just really jumping well ahead in terms of doing some, we just introduced functions, right? So we haven't talked a lot about them, but we've used a few things that are known as methods, and methods are just functions that are attached to objects. We talked about how an array is actually an object, and it's got like the push method. Filter is another method that exists on an array. So it's just a function that's already on that object. And that gives it some behavior, some characteristics. It's a really useful thing to do. And we'll definitely revisit writing this logic with, say, filter later, just to show how it simplifies a fair bit of code. But it's probably generally introducing too many concepts to try and show it right now. So the easier way to work through this is to do something like what we've been doing, which is a while loop. A lot like what I was showing with the even one before. The difference here is you're not necessarily stepping over the same array that you're pushing stuff into, right? You're working with 2 different arrays at the same time. So you've got one that you're using to step through and look at the values from, and one that you're pushing those values into if they match a certain condition. So we can write it out, which is, we'll go ahead and start with what we have here. Again, this was one that had a lot of starting code attached to it. And let's just make sure that that runs as is. And it looks like it does, which is great. Otherwise, I gave you guys broken code, which apparently I did on the last problem. I fixed it since, by the way. So we can start breaking down what we want to do in this code. And we've done a fair bit of iteration over arrays at this point. So I'll move through that portion pretty quickly, which is while index is less than numbers.length. We want to do something in here. Oh, first thing is let's make sure we increment our index. And then what is it we want to do as we're stepping over this array? Check every item. So we can check the one that we're on right then, right? So let's put an if, and we know we want to do something with our original numbers at index, at that position. We want to do something with that, right? We've already done the logic earlier that checks if something's odd. So here's a nice little, we've got that. And if something happens to be odd, now what do we want to do? This is the trickier part. Push it to our new thing, which is our odd numbers. We want to push it. And what do we want to push? The value at numbers index, right? Yep. So let's see if this works. And I think we have a bug. What? We're gonna get an error? Oh, okay. Well, we can fix that. That's easy. Now let's see if we work. Which, hint, I think there's a bug. Ooh, I got a bug. What is it? Ah, yes, see. I'm using the same variable, index, that we used in this earlier loop. But at this point, index has already reached 20, which is going to be the number of items in my, or the length of my numbers array. So it's going to say, well, 20 is less than 20. It isn't true, and it's never going to run this. So I need to put index back to 0 so that I can start again and count over my whole array. So let's see. Yay. Looks like it works. We just introduced functions today. So is there any bit of logic inside of this that looks like it might be a nice thing to turn into a function? Well, let me ask you a question real fast from a different perspective. How easy is it to look at this bit of code right here and know what it's doing? What? It's a little bit of a challenge, right? If I were to say, look at this line and tell me what it, or this expression and tell me what it does. That's a little bit of a challenge, at least to me. So one of the benefits of functions is it makes your code more readable. It gives it a nice, meaningful name. So what if we, and this is cheating because I'm giving you the answer sort of to at least one thing that's going to be a homework assignment at some point. Maybe I won't actually write it, but what if we have a function that returns true or false if a number is odd? And what we can do is change this bit of code to call our function instead. How does it read now? Does it read easier? Is it easier to look at that and say, oh, I think I know what that if statement is trying to do? Right? That's one of the benefits of, that's an example of why names matter. Because if you read that code, you can say, you can almost read it like a sentence. It's almost an English sentence. If this number at this index is odd, then do this bit of logic inside of here. And that also deals with that abstraction aspect, which is, assuming that is odd is written correctly and doesn't have a bug, I don't care how it determines that that number's odd. I could care less how it does it. I just want to know that it works correctly and gives me back the right answer if it's an odd number. So I'm actually not going to write that right now because that'll be one of your assignments. So that way I didn't give you the full answer. You'll have to implement is odd as a function at some point. Any other items from the homework somebody want to work through?
Finding the longest word.
Ooh, finding the longest word. That's a good one. Right? I like this one. People always struggle with this one, which the first time I wrote it, I was very shocked at. And then I began to understand a lot more about why people were struggling and what some of the challenges were. And part of it is I gave you very little to start with. A lot of these other ones I've given you almost all the framework. This one required you to write a lot more of it, which is one of the reasons that I think people struggle with it when they encounter it. So what do you think? Where do you think we should start with this one? I think after this one, we'll probably call it the night, but where should we start?
Well, they was us in the first entry of the array was false. It's not like the policy, array index 0. So I don't.
It's an interesting. There's some really interesting ways you could solve this one, by the way. Let's start with how we know we're going to need to walk over all the items in the array, right? So how do we do that? We've written that a few times. Anybody want to? We need our while loop. We're missing something that we need before our while loop. We need our index. You guys are gonna hate me when I give you the nicer ways to do loops instead of while loops, but that's okay. All right, so we've got our index. What do we check that against? Less than fruits.length. You'll notice, by the way, speaking of how naming is important, this is plural, and that's another one of those naming things. By looking at that variable name, you can imply that that's not one fruit, that probably represents a lot of fruits, which maybe that's an array. I don't know, but there's a lot conveyed in that name that is very subtle. And now inside of here, let's do this even. Let's use that same logic. We're gonna create a variable, call it fruit. And in this case, we'll just get the fruits at the index and store it in fruit while we're in here. So that'll make all of our logic in here easier. We don't have to reference, we've created a nice variable that we can use while we're in here, and we don't have to reference fruits at the index all the time. It makes some of the other stuff simpler. All right, so we've got this. Now, we're trying to find the longest item in the array. How do we check how long? We want to look at the length of the item. So how do we get the length of? I stored that in fruit, so I can be lazier. Dot length. Well, I stored just this one item in fruit. I basically took one thing out of the array, so the item that we're on right now is in this fruit variable, so I don't have to do all that index stuff every time. Save me some time, right? So what am I checking this against?
We have to check it with every word.
I have to check it with every word? This is one of those types of situations where it can be really useful to break a problem down into a simpler one and try and solve the simpler one first. So here's what I'm gonna do. I'm gonna take this whole fruits array, copy it, comment this one out. I'm gonna make a much simpler one. Here it is. We have one item. One item in our array. All right. Yeah, this is going to seem very stupid at first, but we're going to step through this. How do we check whether we're the longest item in our one item array? And let's say we know that there's only going to be this one item. See, that's, I'm gonna get there, but yeah, so what you can do is if you start with a variable and you say, oh, I want to initialize some stuff, if I know that each word in here is going to be some number of characters long, anything longer than 0, then if I say longest word is equal to 0, now I'm gonna bring back our whole array because not that hard, but if I check, so this is going to be in some sort of if block. If fruit.length is longer than, if it's longer than the longest word, right? Because we're checking the length of it against the longest word. Then what do we want to do in that case? Do a console log. All right, let's see what happens. Let me get rid of this just so that my code is a little more compact. See what we get here. Oh, we printed out all of them. That's not what we want. Well, one thing we're doing. Oh, you weren't storing. You had 0 in here originally. Okay, that's interesting. And then you did dot length. Yeah. So in this case, because I changed it a little bit, we can say longest word equals fruit, right? And then, well, do I want to have that there? So like, oh, wait. I see what you're doing. Hold on, yours is a little different than I thought. Let me check this. Longest word dot length. Okay. Hold on. You did it like this, right? I get it. So what you're storing in there is the index of the longest word, right? And so this would actually be longest word equals index. Incrementing our index. And down here you were saying fruit's longest word. I'm guessing we have a bug still right here, but I think you probably wrote it correctly. Because we printed out apple, banana, strawberry. Does anybody see why? Get rid of this line. That's because we're logging every time we go through this loop. It's just printing out whatever is currently stored in longest word. Whereas what we really want to do is move this down. We want to do this after we've finished checking the whole array. So now we just print out strawberry. All right, you've got the longest word. Another way to do this, probably the way I would have done it, it's not, at least if I'm writing it out explicitly like this, is probably even being just a hair more explicit in terms of some of my variables versus storing the index. That's more efficient, actually, than what I would have done. Whereas I like being explicit a lot of times, so I would have something like longest word length equals 0 to start with. And then I would also declare like a longest word as, say, an empty string. And then what I would do is I would say if the length of this is less than longest word length, then I want to do two things inside of here. I want to set my longest word length to be equal to fruit.length. And I want to set my longest word to be equal to fruit. And then, oh, that's because I'm not logging the right thing here. For longest word, that's what I want to log. That's really the same thing. I just used some more variables. I didn't use the index value. A little more explicit in the naming, but it also required more code. Right? There's no right or wrong on the way to solve that between those. They both work. But part of the trick of this is one of the first times you've had to create some of your own variables and think about, ooh, I need to have some stuff initialized and I need to change that value conditionally in some case. So there's a lot of little bits in this programming problem that are tricky the first time you encounter something like this. I hope clarify it. Make more sense? All right. Let me ask you a question now before we're done, which is one thing I was talking about earlier was proposing the idea that instead of just posting the answers to the homework problems, because you can read them, but I don't know if it'll be as useful as just reading how I solved them. I was proposing, assuming I can find the time, hopefully on a weekend, the idea of posting short videos of me solving each programming problem and breaking it down. And that way you wouldn't have direct access to like, oh, here's the solutions. You know, it's like, oh, if you want to see the solution, you can watch the video or jump to the end, but you're seeing it being solved and broken down. What do people think of that? Think it makes sense? Would you rather just have the solutions just posted directly? Videos? All right. Cool. I'm gonna give that a try and get some of those up this weekend for the ones that we've already done. I'm working on converting some of the homework that we've already done and other homework going forward so that you guys will be doing most of that stuff on this REPL.IT platform going forward. I tend to wait until we get to functions to do that because functions have return values, so it makes it very easy for me to write tests against your code to make sure that it's doing what I want. Whereas before functions, it's hard for me to use that platform to do your work or to test your work. So in the next class, we'll talk about that platform and make sure that everybody's up and on it and able to start submitting assignments through there. And one of the great things about that is you'll be able to get instant feedback from the tests to tell you whether or not your code is achieving the expected result or not on the stuff that we have up there. So any other questions before we're done for tonight? All right. Have a good evening. Don't freeze. Don't depress me anymore by talking about how it's going to rain for 3 more days. My goodness.